Alright, so in this video we're going to go one step further than we've gone in the previous video, and we're going to show the link between molecules or atoms of something and a corresponding weight in grams. Now you can really go either way. You could go from grams to molecules, grams to atoms, or from atoms or molecules to grams. It doesn't really matter which way. The system that we're going to use works exactly the same either way. And all it is just a variation on the conversion factor method, the picket fence method, however you have learned it. So let's just do an example. Let's say we have a question along the lines of, let's say we have 20.9 grams of CO2. Let's say we happen to have that much CO2 present. And one question is, how many molecules of CO2 do we have present? So in that 20.9 grams, how many molecules of CO2 are present? And there's one other question that we could ask that's a little bit more involved. How many atoms of oxygen present? Again, in that 20.9 grams of CO2. Well, let's start off with the first question first. Of course, the only thing we can start with is whatever we happen to be given, which, as you can imagine, is the 20.9 grams of CO2 in this case. So let's start with that. 20.9 grams. Oh, box. Hang on a minute. Let me do that again. 20.9 grams of CO2. Now, we want to get molecules from that. Now, we know, whether it's molecules or atoms, we cannot go directly from grams to molecules or grams to atoms. There's usually one thing that we have to go through. And it's the one thing that you'll have seen before, more than one occasion, that you usually get directly from grams. It's an amount of substance of something, it's just not grams. Of course, it's moles, of course. All right. So the first thing we're going to do is to convert a number of grams of CO2 into moles of CO2. So we've got to have moles on the top, grams on the bottom. How many moles of CO2? Well, if you remember, it's always the same. It's always 1 mole of whatever you're concerned about. In this case, that goes on the top. And then where does the number of grams come from? Well, that's just the molecular weight, the molar mass of CO2. Now, carbon's 12.011, oxygen's 16. Put that all together, and what we get is 44.011 grams of CO2 present in 1 mole. Okay. Now that actually gives us a weight, or a number of moles of CO2. But moles of CO2 is not what we want. We want molecules. Now let's see, who remembers, how do you go from moles to molecules, or indeed moles to atoms? It's actually exactly the same conversion factor. As you would imagine, molecules and atoms are very, very small. So the conversion factor that we're going to use has to allow us to calculate a very large number of molecules or atoms. And who remembers what that conversion factor is? It is a very large number, has a name attached to it. In fact, the name attached to it is the name of the guy that first generated the number. And it's called Avogadro's number. And so what Avogadro's number in this case says is that in 1 mole of CO2, we have 6.022 times 10 to the 23rd molecules of CO2. All right? I'm not going to write CO2 here just because I'm running out of space. Now, remember, the first part of that question asked for molecules, so let's check if everything else can cancel out. Grams of CO2, grams of CO2. Moles of CO2, moles of CO2. Oh, what do you know? Let me write it just there so we're sure about what's going on. So, not surprisingly, we are left with Well, the only thing we have. It's molecules of CO2, which is exactly what we're asking for up here. Now, would you expect the answer here to be a big number or a tiny little number? Well, as we have a huge number on top, we'd expect the answer to be a big number as well. And it is. What we get is 2.86 times 10 to the 23rd molecules of CO2. All right? So that's the first part of our question. Ding, answered. Now, how do we do the second part? And I'll give you a clue. It's a very similar setup to here. In fact, it involves almost all of this calculation that we've already done. Let's just think about it for a minute. Again, we have to start from here. So we know, once again, we've got 20.9 grams of CO2. I am going to end up writing out some of this stuff again that I wrote out before, but that's okay. I just want everybody to understand why we're doing what we are doing. First, we went from grams to molecules of CO2, which is what we did here. And then we need some way to relate molecules of CO2 to atoms of oxygen. Well, if you just think about it, if you have one molecule of CO2, that contains one carbon atom, two oxygen atoms. All right? So therefore, in that one molecule of CO2, we have two oxygen atoms. I did the 2 times, so you don't confuse it with 20. All right? So in one molecule of carbon dioxide, we have two oxygen atoms. So does that suggest a conversion factor that we can use along with all this stuff that we've been doing? Because it should. All right, the idea being, well, if we can generate molecules of CO2, which we, if we can generate moles of CO2, we can generate moles of oxygen atoms. All right. In the other way, we can just go from moles of CO2 to molecules of CO2 to atoms of oxygen. We can actually do this 2 different ways, but let's just do it in exactly the same way that we have up here. All right, so we're going to do 1 mole of CO2, 44.011 grams, just exactly as we've done before. All right, and then once again, 6.02 times 10 to the 23rd molecules of CO2 in 1 mole of CO2. But then, in order for us to go from molecules of CO2 to atoms of oxygen, we have to use this conversion factor here. So, if this here is molecules of CO2, and we want to end up with atoms of oxygen here, then I've got to put molecules of CO2 on the bottom. 1 molecule of CO2 gives me 2 atoms of oxygen. All right, now let's just check our units again. Grams of CO2, grams of CO2, moles of CO2, moles of CO2, molecules of CO2, molecules of CO2. So once again, we're left with the atoms, the units that we want. And funnily enough, it's this calculation here is exactly the same as the one up on top, but we're going to be multiplying everything by 2. So really, all it is this answer times 2. 5.72 times 10 to the 23rd atoms of oxygen. All right. Now, one thing to bear in mind: you have usually seen oxygen in this form. You know, that's the form that it naturally exists in. Okay, this is an oxygen molecule. All right. This is an oxygen atom. So when the question asks how many atoms of oxygen are present in something from CO2, for example, don't make the mistake and say, well, in 1 mole of CO2, I've got 1 mole of oxygen. Make sure you don't make that mistake, because it's asking for oxygen atoms. This is not an atom, that's a molecule. All right? Okay, so that's how you go from grams to molecules or atoms, and as you would imagine, you can go back exactly the same way, exactly the opposite way to get from molecules or atoms to grams. All right, thank you.